On our way back from Karlstad, today we stopped in Hastad, in southern Sweden, where we are not meeting James Campbell.
James is a biologist. He works for Ribes in Berlin, for the Leibniz Institute of Freshwater Ecology and Inland Fisheries and the Free University of Berlin.
His research deals with how artificial light affects the behavior of migratory fish at night.
The lights under bridges, those of dams, streets and cities, can all attract some fish, such as salmon, and therefore slow down their migration and increase the risk of being preyed upon.
The lights may also scare away other animals, such as eels, acting as a barrier.
James works in Berlin, but a small experimental part of his work is here, in this old mill in Hastad. Just as there was at Florian's site, there is a trap and a fish counter with a camera here too.
James is in Berlin now, but he was here a month ago and shot some of his work for us.
So my daily routine is every morning I wake up, I go to the wolf trap where I catch my fish from the main river. I take them and I pit tag them. It's just a little sensor that tells me when a fish passes by my camera trap. Then I let the fish rest for the day. Then at nighttime, I place them upstream of the river. And then I open the camera trap. And then I just wait and see how long it takes the fish to pass the camera trap. And every day, I'll alternate the camera trap so the light is either switched on or switched off. So we can see if there's a difference if fish pass when the light is on versus when the light is switched off on the camera trap.
Finally, 2 months later, we meet James in Italy, in another mill.
He explains to us that 10% of his work is spent in the field in Ostad, and 90% is analytical work spent on the computer.
Field work is essential. It allows James to acquire direct and intuitive knowledge of the species he is studying, and allows him to collect data on the behavior of the fish, and to follow their movements in detail.
The other part, the analytical work, on which he is most concentrated now, aims to acquire a more general view from above.
Starting from the statistical data collected in several experimental sites in various conditions, James' work consists in creating theoretical models of fish behavior and refining their parameters.
If the models are good enough, they can then be used to make prediction on fish behavior in new environments where little or no data has been collected. This is particularly helpful for predicting how fish will behave around new structures.
James explains that, from his experience, biologists like to rely on statistics in order to answer their questions, while engineers rely on simulations.
His goal is to build bridges between these two disciplines or languages, mathematical bridges, to allow them to understand each other better.
But the topic of how artificial light at night affects fish is really new. We kind of suspect it has an effect for a long time, but the actual research and collecting data on it hasn't really happened until just a few years ago. So it's kind of a very pioneering field because we're still collecting enough data to understand, okay, what are the right kinds of questions we should ask on this topic? Yeah, it's fun. I love it because my favorite part about my work is because I don't have other work in my field to kind of get inspired from how do I make these models, how do I ask these questions, I get to look into other fields. So for my theoretical modeling, a lot of my work is focused on applying a method called approximate Bayesian computation. And this is a method that is primarily used in computational genetics right now. So it's really exciting to bring a method that's been established in another field and see if it can apply it to my field.
Foi marinheiro, foi os peixinhos do mar, que me ensinou a morrer, que me me ensinou a morrer. Foi marinheiro, foi os peixinhos do mar. Foi marinheiro, foi os peixinhos do mar. Que me ensinou a cantar, que me ensinou a cantar. Foi marinheiro, foi os peixinhos do mar.